so tell them it's like it's available in YouTube live, because I'm going YouTube live, so they can watch from there. Is someone is recording? So let me send them. We'll see. Just 2 minutes, guys. We'll start now. So can we start the session, guys? So let's start because I know only 3 people join. And you. So any idea about IPv6, guys? What is IPv6? So any idea about the IPv6? So what is the main purpose of IPv6, guys? Before we jump for IPv6, so let's talk about your IPv4, okay, which has got 32-bit. Okay, what is the size of IPv6, guys? Clara and Andrew or Sahil?
128.
128.
Yes, perfect. So 128 bits. And this is your 32-bit, right? And what is the reason they introduced IPv6? First, tell me this. What are the reasons why they introduced this? One more thing, guys. Please tell to your friends those are not unable to join. So I have I put live in YouTube. So if they are unable to join, so ask them to join from YouTube, because right now we are all live in YouTube. Okay, so let's come back to the topic now. So what is the reason why they introduced, what is the main purpose of IPv6? Why they introduced? Yeah.
So the IPv6 is there to help solve the problem with IPv4, with the limitations of how many IPs are there. So because IPv4 is running out, IPv6 is here to provide the solution to give abundant number of IPs.
Okay, so it means we are getting more number of IP addresses, right? So
Yes.
we are getting like many IP addresses, okay, in IPv6. So there is a limitation for your IPv4. Right, so I think in 2012, the assigning the IP address of IP has got over. Okay, so there is a temporary solutions after that IPv6, like their temporary solution which we did, right? Natting. Correct. So NATing we did. This is the temporary solution, guys.
Yeah.
The permanent solution is your IPv6. Okay, so let's discuss this. It's a large address space, globally reachable and flexible. So aggregation, multi-homing, okay, auto configuration, plug and play, end to end without NAT. So as I told you that it doesn't require your NATing. So it's not required your NATing part. So renumbering also is, we can do it. Simple header. So IP headers is very complicated there. So where here it's quite very, very simple. Right. I think you can see my slide, right? All of you guys?
Yes, we can see it.
Okay, what I'm writing on the screen, like you can able to see, right?
No, I can't see you writing.
Oh.
Yes, the PowerPoint presentation.
So let me check this. Okay, so now if I write something, I think you can able to see, right?
Yeah.
Yeah. So what I'm trying to explain, so the IPv6, so as I told you that, okay, IPv4, okay, the assign of IP address to 2012, assign IP address got over. So if you talk about now, okay, the temporary solutions they handed you, that is your NAT. Okay, using NAT, we can get some IP address like this is the temporary solution. And permanent solution is your IPv6. If we talk about IPv6, guys, we can see, so it is a large address space. So global reachable and flexible, aggregation, multi-homing. Any idea about multi-homing, guys? Auto configurations, plug and play, end to end without NAT, doesn't require any NATing, as I told you that. It's not required NATing, IPv6. So NAT, what you learned here, what I taught to you, so it will be only for the IPv6. Okay, it's very easy. So plug and play, end to end without NAT, renumbering. And header for IPv6 very simple. It's very small. Even though it is 128-bit, the size of IPv6 size is 128-bit, but still it is a very small header. So routing efficiency, performance, forwarding rates, scalability, no broadcasting, no checksum, extend header and flow label. So what are these things, guys? Let me explain what is this aggregation, like what is a multi-homing. So multi-homing is nothing but like redundancy. So one links go down, so it will go to another link. That also it will support your IPv6. So whether you have connected the two links, okay, so example, two ISP with your router. If this ISP goes down, so the traffic will route. That is one example, like redundancy, it will act as a redundancy, that is called multi-homing. So plug and play is very simple, auto configured. That also we can make it configuration for that. Auto configuration. Now, if you talk about more details about, so what exactly this IPv6 advanced feature is, mobility and scalability. So mobile IP RFC complaints. So it's also support the IPsec mandatory. So you are familiar with this, guys? Are native for IPsec. So IPsec is a protocol. Your IPsec is a protocol. So you used to configure for your VPN. So maybe site to site. Okay, I site to remote. IPsec protocol. So that one also it will support, guys. Remote. So transaction richness, dual stack, 6 to 4 tunnel we can create, and translations. So we can create using IPv6 up to 6 to 4 tunnel. So which is very good advantage, guys, for network engineer. So it will give the like scale up, very huge scale, for configuring for IPv6. Okay, configuration is same like IPv4. Instead of IPv4, we have to give the IPv6. Of course, the length is very bigger. Okay, so this is look like this. So as we can see, this is your IPv4 and this is IPv6. So 128-bit. So 32-bit of 4-byte long. So this is a possible IP addresses where we can connect for your computers nodes. In IPv6, guys, so this is a 128-bit or 16 bytes, 4 times the bits of the IPv4, 3.4 into 10 to the power of 38 possible address. Means this is the total number of IP address we can get in IPv6. I don't know like how many trillion or how many billion, how to say this. Okay, 5 into 10 to the power of 28 address per person. Means in another 100 years, so you'll be using your IPv6. Okay, guys. So addressing space, how they are designed, like cloud address space enable the like address aggregations. We can see these are customers, the customer number. So this is the IP address look like /2048. So it starts from 2001-04. We should discuss about this. Okay, so analyze only 132 bits prefix. So usually the internet, so they will use maybe 32 or 16. Okay, this indicate it has been it is from the internet. When you talk about the 48/48, this indicate that it is a you're using for private network. Understood, guys? Guys, are you there?
Yes.
Yeah. See, if you talk about the header, how it look like? See, this is the IPv4 and this is IPv6. We have the very less parameter inside. Whereas IPv4, we have a lot of parameters. It's very simple or more effective header means 64 bits align field with the favor field. Hardware-based effective process, improve routing efficiency and performance, faster rates with the better scalability. So it has got a scalability is very huge. Let's talk about the header layer, how it's look like. Okay, so this is the header layer, how it's look like, guys. You can see, right? Do you think it's very simple, right? See, look how our IPv6 look like. Like Brishan, HCL, services, total length, identification, flag bit. Okay, a lot of parameters we can see, like padding option. So whereas IPv6, what we can see? So versions, traffic class, field level, payload length, next header, hop limit, source address, destination. Khalas. Very simple, right? Of course, only length is bigger, and it has got very easy for network engineer to trace. So this IP address what it contained, because most of the organization they will ask the header, IPv4 and IPv6 header. So you have to remember this. So version, traffic class, flow control, payload, and next source address and destination address. So if you talk about more details here, see extension headers, IPv6 headers. Okay, any number of extension headers. Okay, data might be, for example, TCP or UDP or any other streaming traffic. Streaming traffic is, as you know, just I told. So right now we are in live in YouTube. Right. So this is nothing but I will call it as your traffic streaming, like live streaming also we can say. So this all we'll call it the IPv4, IPv6 packets. Okay, similar and more effective header means IPv6 extend the headers. It handle option many more efficiently. It enable the forwarding rate and end-to-end node process. Okay, the processing also quite very simple. They are made very simple, guys. If you talk about more details, means they made very simple. Okay, we can see, guys, this is the format, guys. So how it look like? So where X is the 16-bit hexadecimal value, case sensitive for hexadecimal. Case sensitive, guys, is a very case sensitive. Okay, leading 0 in the field of option. And this is the one IP address what I have given, 2013:0:0:30 130F :0:0:9CO:8736A, okay, and 13:0B. Such field 0 can be represented by : right? So if it is 0 means rather than just we can write : like this. Here we can see, right? We can write like this. But once, okay, only once per address, not twice. Suppose if you're getting the 0 like this, guys. Okay, so you can use only one time, whether this or this. You can see example. So where he has given 0:0 here. So he has used only one time : we can see, right? 2 times has given, 1 time he has used the : means this indicate that it will consider automatically your 0 there. Or else incorrect means some people they write like this : here is 0, right? Here is 0, they will write : which is wrong. We should not use like this. Okay, and we can here also use the : so which is incorrect. Okay, so now this is the address like this. If it is available, this is the starting address, starting all 0. So how many octet, guys, here? How many octet, guys, in IPv4? How many octet?
Before
24 octet. Is it correct? 24? Is it correct, guys? Andrew, see, 4 octet for IPv6, right? IPv4. That is your 32-bit. Right? 32-bit. Okay. If it is 12 octet, how many bit it will become? Guys, can you tell me here what I'm asking the question here? I'm asking question like how many octet in IPv6? So this is my question, guys. Who will tell this answer, guys? Clara, can you tell me?
this 16 octets.
Yes, it's 16 octet, which is already written, right? It is a 16 octet. So these are types of some concept, guys. So I would like to emphasize these points, guys. IPv4 addressing types, if you discuss here, so it supports the unicast, multicast, and anycast. Okay, these are the few important points, guys. Okay, so you should remember. Okay, unicast, multicast, and anycast. Okay, what is unicast? So as we can see, okay, unicast globally, okay, unicast like your public IP for routable. It's like your public IP, starting range for 2000:3, where the first 3 bits 001 assigned by your IANA. I think you might know about IANA, right? So example 2000::3, where 3 is a fix, where bit has been for your, where 2 has a 4 bits. Okay, IRM is, right, Internet as an numbering authority. So this is the American organizations, one of the private organization who will manage your IP addressing concepts. So unique local, so like your private IP address, so example, your class A, class B, class C in IPv4, class C, where starts from your FC00::7. So they are not routable in the global IPv6 internet. They are not routable because we can use your internal network for assigning the IP addresses. So they are not routable in the global IP address, starting range for FC or FD with the first 2 numbers. Okay, FC or FD, you can use any one of these. Like this, how he has used here. Right, yes, how he has used here. Okay, so what is local? Link local. So IPv4 address is on every IPv6 enable interfaces like non-routable. So where it starts from FF80. Last, router do not forward packet with link local address. If it is a link local, router will not forward the traffic. Remember, guys, it will not forward your packet. Okay, one more thing is multicasting. I think you know multicasting, right? Example, like he has given some example, FF80, this is used for the local, your LAN links. For your internal network, we can assign these IP addresses. And multicasting, so IPv6 multicasting address will be started with FF, this address. It is like your class D address in IPv4. So multicasting, I think you know, right? Multicasting IP address which starts from your 224 to 239. I'm correct, guys? Class D in IPv4. Okay. So any cast address that assigned set for the interface typically belongs to different nodes, similar to your multicast. Identify the multicast interface, but send only once whenever it find first. It will send only one time, not every time. Unique local and global unicast address can be used as any cast. Unique global and global unicast address can be used as a at any cast. We can use that as a any cast. There's an advantage in IPv6. So this is a look like, guys. You can see on your screen IPv6 global how it look like, any cast addressings. So this is quite very important, guys, because you know when you go for any interviews, any organizations regarding the IPv6, so they'll ask these parameters. So first 23 bits belong, it is a registered word. It is registered for first 23 bits. So up to 32, it is a ISP prefix. Whenever you see 32 means that indicate that it belongs to the ISP IP address. So it is 42, it is a site prefix. So subnetting, if you give the /64 means you have done some subnetting. So here we did not do any calculation. How we are doing subnetting, I want 5 departments or 8 departments, how many IP address I will get in each department, how many network we will get in each network. Here is not the case. So here just give /80, it will consider automatically. As usual, this is last your interface ID. This is what it's talking about. Similarly, global unique address cast. Whenever you see this /32 means this is your ISP, as we have mentioned here. Eventually, this is called the ISP. The single interface may be multiple address or typically unicast or anycast. Every IPv4 enable interface must contain at least one loopback. Okay, the loopback starting from a ::1/128 is one link local address. Okay, just for activation, the key polite message how we are sending. Okay, here also same concept, guys. Optional, so every interface can be multiple unique and global address. So any cache address might be set typically one of the address. So IPv6 can we use multiple homing or several IP ISP with having the multiple connection to each other? So maybe I think it's not like that only this can be connected. So this range will be differ. Okay, inside within this range, it can be changed, but they can communicate to your other ISP as well. So example, this is ISP A and this is ISP B. Okay, so one more ISP, ISP C. So they can have the communication to each other. This also is going to support your IPv6. What is the link local address? 132 bits. As I told you, that is a interface ID 64 bit. So when you talk about first this FF86, that 10 bits. So have a scope limit link other of your dynamically created IP, all IPv6 servers using a specific link local prefix. So what is talking about, guys? Local link address also automatically configured. So this can be also configured as automatically we can configure like network discover, router discover, link local address are also used for the many routing protocols. Automatically we can assign like how our DHCP is going to work. Same thing here. So like how automatically also is no need to give like manual IP address. 132-bit assigning the IP address is very difficult task. So it takes a lot of time. It consumes the time for the network engineers to assign all the suppose. Just imagine if you have like 500 PC, so you ask, so you was asked to assign the IP address for all 500 PC of IPv6. So it takes a lot of time to assign, right? So in that scenario, we can assign your dynamically IP addresses. So when communication link local, so you must specify the outgoing interface because every interface is connected for FF80/20. Okay, so this is what he's talking about. So he's connected, it must specify the outgoing interface before because so every interface is connected for your FF80::/10 just for identification. Okay, if you want, I will share you this slide, guys. Do you want these slides, guys?
Yes, please share.
Yeah, no problem. I will send you that. See, so what is this is talking about now? So EUI. Okay, so any idea about EUI, guys? 64 to IPv6 interface identifier. One is a universal unique, 0 means local unique. Any idea, guys? If you want, you can Google it, guys.
Extended unique identifier.
Yes, very good. It's an extended unique identifier. So what is talking about here? So U/L bits. So where U contains, this U contains universal unique, okay, and local unique. One, if it is 1, it's a universal unique. 0 means your local unique. So if U is 1, that indicates a universal unique now. So we can modify this your extended universal. What is it, Andrew? Extended universal identifier. Okay. So this a modified EUI64 addressing format is inserted by inserting your FFFFE and complementing a bit identifier the uniqueness of the MAC address. So what is that? He's just replacing with this FFFE. Okay, this will understand it is nothing but like it will become your unique identifier. It will become your unique identifier in that. So as we can see, continue with the same bit because he's just inserting these two these bits. That is it will become your Ethernet MAC addressing of 48 bits. A modified UAB address format inserted FFE and complementary bits identify the uniqueness of the MAC address. So this indicates it has become a unique of MAC address. When you inserted this bit in the field, so this guy will become your unique identifier. Okay. Same thing. So here is he has inserted now. You can see. What is multicasting, guys? Any idea? Any idea about multicasting? So what you can able to guys tell me what is flag, guys? Any idea? Any idea about flag, guys?
To my side, no.
No. Okay. What about this in Clara? It's like a flip-flop, guys. So flag is it is nothing but the identification of the bit for specific task. Remember, guys, group ID. So multicast casting what is talking about. Okay, there is 16-bit up to here, the flag and scope. If we flag talk about 0 is permanent, 1 is temporary. Scope. So where it has got this all parameters. Okay, so interface long, local link, subnetting, administrative local, site local, and organizations, and Eve for your global. So these are the parameters, guys, in the scope is available. Depending upon the combination of the bit, okay, is going to change your multicasting. Okay, same thing, multicasting IPv4 starts from 224, right? Same thing here. Here is a different concept. So when we when you do some lab, I think there we can understand, guys. Example for the permanent multicast addresses, we can see for all means for all the nodes, okay, starts from FF02::1 and 2::2 is for all the routers, and this is for the nodes, and for 9 FF02:9 is for all the RIP routers, and this is for the local. FFF this is X and colon and XXX. This is for the solid nodes, and 101 for all NTP servers, network time protocol. So these are the fixed one. And any cast, I think it has got only similar this pen. If we talk about here, we can see prefix with n bits and 128 n bit for interface. So IPv6 any cache address globally unique cache address that assigned to a more than one interface. You can assign more than one interface, guys. So any idea about what is SSL, guys? What is SSL, guys?
Secure socket layer.
Yes, very good. SSL and TSL, handshaking protocols. Secure socket layer, and it's a newer version of the transport layer security, TLC, or encrypted protocol that provide the security on the internet. Right. Suppose like when you open, say, let's say, let me open our website. So this is our website, guys. If you open our company website, so we can see it is locked. So we can see this is a secure one. Okay, site settings, cookies. If you open that, this is the secure website. See, it is become like HTTP automatically, it's become HTTPS. Okay, it is a secure one. So this is our website, guys. I think just go through our website. What I'll send you in the chat. You can visit our company website. So because why I'm sending, because we are developing, designing the workbook, like cookbook for all CCNA, CCNP. Okay. Did you receive it, guys? All of you? Okay.
Good.
Got it, right? So we can visit our company website. So we can see our team members, our technical heads, our programs, our madams, our staff, our programs like Cisco, Microsoft, AWS, Azure, Kali Linux. Okay, so let's come back to our topic now. So let's talk about what is this is talking about. See, first understand our cryptography protocol that provide a security on the internet, provide privacy and security. Which one? This SSL and TLS. Okay, up to today, 2018 SSL version 3.0 is version most web servers and browser supports. Okay, so most of the web server and internet, so they use your SSL version 3 till now. Okay, now I think we are using TLS now. Okay, or an SSL. SSL, I think version, I'm not sure which version we are using now. So I need to check this one for secure communication. So what is this? It's like your handshaking protocol, guys. Hello message, SSL, TSL versions, your cryptography algorithm are used, data compression methods, server say hello. Okay, how they will exchange the message between your server and the client. The cryptography or algorithm are agreed. Okay, section ID, server digital signature will be authenticated, and server public key. If the two matches, then only they will deliver the content to the client. Suppose if you talk about more details here, the client exchange the key. So in the previous slide, if you talk about this slide, I think coming slide is there. I'll show you that. A shared security key encrypted with the server public key. Finish the client message and crypto with the share key with the handshaking. So it's like handshaking, guys, because when you authenticate it means, so then only it will accept your request. Finish the server message encrypted with the shared secure key handshaking compliance. So once the connection established, the server and the client can now exchange the message. So how it will exchange the message? So as you can see in this way. So this is how. So the client is going to request always, right, to the server. Okay. When you request service, the service is replied. He reply with the service, what kind of you want to do. So client will send the hello, server also send the hello. Okay, exchange the key. If he has the key, okay, then only server will check your authentication. That authentication, what we call crypto algorithm. This is the algorithm which will check this authentication. Okay, and finish the client and finish the server. So this is the nothing but your handshake process, SSL and TSL. Okay, guys. So like, if you want, I will share you this slide, guys. I think IPv6 is not much to discuss here. So even like I2, I don't want to discuss much more about IPv6. Let me, I will share you this. Yeah, I think now we can see. I hope you received, right? Received all of you guys?
Not yet.
Not yet?
I've not received yet.
Okay, let me check. Why you are not received this thing? Now you check, guys.
Not yet. Maybe because of the chat type that we're using. We can only receive from, is it read.ai meeting notes?
No, okay, I think that should check if it's only sending to read AI.
Okay, I think I need to close that guy. I think. Yeah.
Yes.
So let me. I think read
Just
AI
send it to
meeting.
everyone.
So I think. How do I close this guy? Let me try now. I think Clara has sent the hello, right?
Yes.
Okay. I think now I can able to send it. Something I did today morning. I don't know why. I do a lot of experiment every day. I have closed this guy. I don't know why it is again showing here. Redmi. I don't know why.
I think on sending option, you should select everyone.
Yeah.
Let's see. I think now I can able to send. Let me try once again. So now you check, guys, whether yeah. So now I have sent you. Yeah, I think now you
Yeah.
should try.
Yes, thank you.
Okay. So what I'm going to do, guys, so let's start the lab now. So the lab, what we're going to today, we are going to discuss, that is your ether channel, guys. Okay. Yesterday I told you, right? Today we are going to discuss about your ether channel.
Yes.
So how many are familiar with the ether channel, guys? Any idea about ether channel?
Mhm.
Any idea? Clara?
No.
No idea about Ether channel? Okay, so let me share you my screen first. Any idea about Ether channel, guys? Yesterday I had given some idea about Ether channel.
Okay, I just know it is used to like make different interfaces to be like one, like bundling them up.
Mm-hmm.
Mm.
Like, can you come again?
Bundling up several links
Yes,
to be
bundling.
like
Very good.
one
Yes.
link.
Yes, very good. Okay, so did I explain the per VLAN spanning tree for you guys yesterday?
Sorry?
Yesterday, did I explain per VLAN spanning tree protocol?
Yes,
Yesterday I explained, right?
we did the lab on that, I think.
Yeah. So then today we shall discuss about the Ether channeling. Then we'll jump for your RSTP Ether channel. So Ether channel can be done the two types, right? I think inter-VLAN routing, we already did that one. Right? Yesterday we did, right? Inter-VLAN routing, that all and stuff we did. So let's discuss what is the Ether channel. So as I told you that yesterday, so Ether channel is nothing but a bundling the ports. Okay, we'll also call Ether channel or port channel, guys. So your Ether channel so we'll also call the link aggregation, also we can call, and we'll also call your port channel. So what is the main objective for this? What is the main objective of this? So let me write it on the points so that I can able to share these points. Okay.
So before we proceed, are we doing any lab on IPv6?
No, because it takes a lot of time, because just what are the routing protocol we did, like RIP, PHRP, static, OSPF, same thing. Instead of your IPv4, we have to give the IPv6. Okay, so if you want, I'll share you some previous files in packet tracer which we did. So that file I'll share you.
Okay.
Same static RIP, how you configured, same commands, no difference, just IP address change, that's it. Instead of IPv4, just need to give the IPv6. Understood, guys?
Yes.
Because it takes such a long time, right? Because rather than it's quite very easy to configure, because other than like basic concept I explained. Okay, so let's do that. So what I'm going to do this thing here, that is your Ether channel. So Ether channel also called, you call as a link aggregation, or also called port channel. Okay, so now if you talk about the what is the Ether channel. Okay, so first point I would like to emphasize here, that is your combining multiple physical links into a one logical link. Okay, the second point is increase bandwidth. Increase bandwidth and provide redundancy. So these are two main advantages of our Ether channel. is combining the links. So how is the combining the link is talking about? So let's say, so you have the two switches. So example, this is my two switches has been connected. So I'll be connecting. So these are the 4 ports. So in this fashion, I'm going to connect it. Okay. So here, so I can make the bundling. Okay, say 1 has got say 1 gig speed. So totally we'll get how much? 4 gig. This is called your ether channeling. Also, we can say link aggregation or port channel. Okay, so this is my switch 1 and this is my switch 2. So this is how we are going to configure there. Okay, so let's talk about the one more thing. So how do we configure? The configuration part is is very simple here. So ether channel configuration. So how do we configure this? So manually we can configure. Okay, or dynamic. Okay, using negotiate protocol or negotiate protocol like your LSAP or PAJP. Okay, what is this, guys? So what is this thing is if this is a Cisco device and this is the Cisco, okay, so protocol are used by to configure the ether channel. Will configure that is your PAJP. Remember, guys. Understood, guys? If the device is different, say example, you are using different device here. Maybe you are using HP switch. So then when we can make the bundle for other switch also, but here we are using LSAP. Okay, LSAP means link aggregation control protocol. PAJP means your page aggregation protocol. Understood, guys?
Yes.
Okay. So there is some modes, guys, you should remember while configuring ether channel modes. If you talk about the modes, let's say I'll write it down here. Modes and result. Okay, if the mode is on, we are using the PAJP. Let me do directly, guys, rather than writing here. So one is auto. Let me write it down directly. So just to avoid the confusion. We are going to do the lab for these guys. Don't worry. We'll do the lab for this. So let's configure this, guys. So because already I have the file now. Okay, so we can do, I'll show you directly or else I can do right from scratch. Okay, it could be better to, let's do directly right from the scratch. So they want to write some important points here before I could start jump for your lab. So first remember, like how many links we can do it for either channeling mode. So let me write it down here. That is your third point. That is up to 8 links can be used to combine into one logical link. Up to 8 links we can do it. So ether channel can be configured up to your layer 2 and layer 3 also. So ether channels can be configured as layer 2 and layer 3. And it also do the load balancing traffic between the links. Okay, the port channel is logically installed for the physical interface. So these are the few important points, guys, what I have written here. So you should be able to understand this. So let's do that, guys. So very simple lab, right from scratch, we'll do it. Okay. So let's take the switch, or let me take switch this part here. I will do lab it. I will do lab here this time. So this time I'm going to use 4 links. You can use this way, whichever you like, you can use, guys. It doesn't matter. Let me use like this. So what is the first thing is we should do, guys? This is my switch 1 now. Okay, so go to global configuration mode. Okay, let's just give this is my switch 01. So what is the first task I should do? So configure the 4 links should be appear as the one logical link. Okay, port should be negotiated using the Cisco proprietary method. Cisco proprietary is nothing but your PAJP, guys. You can see. So this guy is a root bridge now. If you type show spanning tree, you can see this is the root bridge, because all links are into forwarding state. We can see right here. You can see all links are up here. So here the few links are down. So let's do that. So what is the first thing you should do? So go to global configuration mode. Okay, so interface range fast Ethernet. Let me check which are the interface 1 to 4. Fast Ethernet 1 to fast Ethernet 0/1 to 4. 4 interface. So here the command is little bit different, guys. Please pay attention here. Okay. Channel protocol. So channel protocol, we are using PAJP because both are Cisco device, guys. Remember. Always remember, guys, this is quite very important. So when we are using LSAP means, okay, to whom we are using this LSAP? This LSAP, if it is a
Different switch.
if it is a one is Cisco, another one is a different device. Say example HP or Dell. Okay, if the PJP or PAJP means Cisco, like how we are using here. Okay, so let's do that. So right now we are going to use the PAJP. Okay, then channel group. Okay, channel group, how many we can give? We can give 1 to 6. Okay, right now we can give 10 or whichever number. Right now I'll give, I think 4 I'll give here. Let's say I'll give 10 and give the question mark. So it's not taking 10 because, you know, we cannot give more than 6. So I'll give 6. Channel group 1 to 6 is asking channel group 1 to 6. So let's say I'll give 4. Why is not accepting? So channel group I'll give 4. It's asking again like modes. Yeah, understood. Okay, so mode. So mode, guys, one should be desirable, other should be auto. When you're going to configure these guys, so this guy, if it is this guy is a desirable, and this guy should be auto when you configure that. So let's do that. Okay, mode, I will give this guy as a desirable. You can see if you give the question mark here, it will give the option, guys. It will give the option. So mode, so what mode I want to give? I want to use a desirable this side. We can see the all links is down now. Okay, so now this is done here. If you type show ether channel summary, so we can see S and D. What does it S and D indicates? Okay, that is capital S, right? Layer 2. Capital D. What is capital D? Is showing down. SD means. So port channel, what we did? Port channel 4 we have made. Okay, protocol we are using PAJP. Which are the ports we are used? 4 ports. We are using the 4 ports. Okay, so this is done here. So now we have to jump for your second switch. Show ether channel summary. So it's not showing anything, empty. Can you see now? Because you are not yet configure anything here. Okay, so let's configure this. So this is my switch 02. Okay, so what is the first thing we should do? Do interface for Ethernet 0/1 to 4. Right? Channel protocol PAJP. Channel group. Okay, channel group, I think I have given 4. Mode. Okay, this I will give auto. Okay, so this side I will make it as a auto. So exit. Now we can see show ether channel summary. So now we can see it is still down. You can see, right? Layer 2 status is down. We type show spanning tree. So it is learning still. Right? Can you see now it is like listening now? The link is coming down. The cost has been changed. Can you see here? The cost has become 7 now. Now it is coming up. Let's increase this one so that it will come up fast. So let's check this guy now. This is a forwarding stack and show ether channel summary. Now we can see S and U. S means layer 2. Okay, U. What is U? In use. Previously it was showing D, right? Protocol PAJP. These are the 4 links we are using it. Like show spanning tree. The cost is showing 7, right? Can you see? The cost is the bandwidth increase, right? The bandwidth has been increased now. We have made the bundling already. If you check in layer in this switch now, like show ether channel SU, capital SU means capital S means layer 2, capital U is in use. Previously it was showing down. Now it is in use. If you type show spanning tree, okay, designated port forwarding, the cost is 7. It has increased the bandwidth now. Understood, guys? This is the layer 2 ether channel. Any questions here? Clara, Andrew, any questions here? Any question? If you have, you can ask me before we jump for another lab.
Yeah, you've said that it has increased the bandwidth.
Yes.
By how much?
7. Bandwidth,
Okay.
the cost is 7. Previously, the cost is how much? 19, right? For each link. 19. Now it is increased.
Okay.
Okay. So how to make this trunk link now? Now this we made it bundling, right? Okay. How to make this trunk link now? How to make? Go to global configuration mode. Okay. And go to your internet interface port channel. Port channel 4, right? We have given. Do you remember? Okay. Port channels, then go to that one, switch port, trunk, encapsulation will not work here. Switch port, mode, trunk. Okay, switch port, trunk, hello, VLAN, all. Okay, so and same thing for second switch as well. So go to global configuration mode, interface, port channel 4, okay, switch port, mode, trunk, switch port, trunk, hello, VLAN, all. Okay, show interface trunk. So this is the port channel. Can you see here the port channel 4? Here became the trunk click now. This is how we can check now. Understood, guys? So we can see, right? Port channel, all the ports are this thing, like show interface. The command is show interface trunk. But 802Q all automatically has taken, because it is a layer 3 switches. So we will do the layer 3 ether channel. Same thing. If you check this side, show interface trunk. So this guy has become the trunk link. Understood, guys? If you talk about like one more command is there, suppose show ether channel summary, right? Show ether channel summary. So port channel, PHP protocol we are using. These are the 4 ports we are using it. S and U in use. Layer 2, it is in use. Okay, guys. Understood, guys? Any questions here?
Understood.
Andrew, let me write. This is ether channel. This is layer 2 ether channel. Layer 2. Okay, so you want the commands also, right? Okay, I will share this file right now. Okay, where is the chart? Okay, guys, I think you have received right file.
Yes.
Okay, the text files also I have shared you, both the files. Okay, the next lab, what I'm going to do, so we are going to do here layer 3. Layer 3 ether channel. Okay, layer 3 ether channel lab. So can you take small break, guys, if you don't mind?
After this lab.
No, just I want to take break for just 15 minutes because I'm fasting.
Okay.
Okay, so we'll take small 15 minutes break. We'll come back. We'll do this lab. Okay.
All right.
Okay, guys, I'm back now.
I'm back.
Yes. Guys, I want to announce that today will be the last day of the training, guys. Because Ether channel is the last topic. Because after that, I'm going to start with some basic network security like PAP, CHAP, all and that. So after that, we'll this complete year this free CCNA training, guys. Okay, guys. I think Clara is joined. Clara, Andrew, and Sal. Only 3 people. Yeah. Okay. So let's see command, guys. Sorry.
Hello? Okay. Oh, you're saying
Clara.
today is the last day?
Yes.
Oh, okay.
Yeah. Because I'm going to start the layer 3 because next week I have the other training part.
Okay.
So I have the other schedule. Okay. So after this completing this topic, guys, we should discuss the other topic like how was the training, because I want to know the feedback from your side, like how we can improve. Is there any opportunity in your country, like how we can collaborate, how we can work together? That thing we shall discuss.
All right.
Okay. So let me complete this topic. Okay. Okay, so now I'm going to configure the layer 3 Ether channeling. So as I told you that your Ether channel also can be configured in your layer 3 as well. Okay, this is our layer 3 switch. So as you can see right now, yeah, so it could better connect like this. Okay, so these are 2 layer 3 switches, guys, which I am using it. So for that, okay, in order to configure the layer 3 port channeling for this switch, the member port must be configured with no switch port command before reaching the port channel. Okay, we should give the no switch port. Okay, so right now this is our layer 3 switches. I say no. Okay, show VLAN. So right now there's a no VLAN inside because we are not yet configured anything. Okay, so first thing is just change the name. So this is my switch 1. Okay, so what is asking us to do? No switch port. So no switch port. For the which are the interfaces? Like he's asking, see if you type no switch port, so he's not going to accept. Okay, how we can use this command? So like which are the interfaces you want to make? Interface 1, 2, 3, 4 up to 4. Okay, interface range fast Ethernet 0/1 to 4. Now we can say no switch port. Okay, so now this will become your layer 3 now. So then what it became is it will convert to your layer 2 to layer 3 now. So now it will become your layer 3 now. Same command, which are the things we configured, same thing we can configure. So how we configured previously, guys? Do you remember? Channel group with a question mark. So see here is supporting up to 48. Can you see? Right. So channel group, I'll say 10. So mode. Okay, these I'll give desirable. I think we have not make channel protocol.
Yes.
Okay, channel protocol. So which protocol we should use? PHP. Okay, we have given 10, right? So what next we should do? Any idea? What we should do next?
Should there be an IP address?
Why IP address? Show Ether channel. Show Ether channel summary.
Oh, I thought layer 3 meant we're going to have an IP address
Yeah.
in the link.
See RD, capital RD. What is R here? We can see that R is layer 3. Can you see?
Mhm. Yeah.
All right. So we can see from here. This RD, we have given a channel group 10, capital R and D. Capital R is this, you can see, right? Okay, D. So now it's showing D down because only one side we configured. So this side we not yet configured it. So we have to configure this side. So which are the port we are using? These are the ports we are using, PAJP protocol. Okay, so let's do that for other switch as well. So this is my switch 2 now, and this is quite very important, Andrew and Clara and Sahil, Ether channel. Because in Cisco switches, in data center switches, also we are using configuring this port channeling or Ether channeling. So let's say this is my switch 2, interface range, path Ethernet 0/1 to 4. Okay. No switch port. Then channel protocol, PAJP. Channel group what we have here, it should be same, 10. Okay, mode. Okay, so which mode? This side, it should be auto. That's it. Show Ether channel summary. See, still it is showing down. So what could be the reason, guys? So now it is coming up. Can you see? Still is coming up. Still U. Can you see what is it? U.
In use.
In use. You can see, right? RU. Okay. R means layer 3. U means in use. So let's check this guy. So yes, this also became your layer 3 configurations. So can you do for the router, guys? Router is a layer 3, right?
Yeah.
Can you do for the router? Can you try? Okay, so let's connect, see, let's what happened. Okay, this is my router. So let's connect to this switch. Okay, let it be. Right now, I want to use only 2 links I can make. I can make 2 links as well, no problem. These are gigabyte, these are. So it is possible to make the Ether channel for this guy as well. So example, interface, fast Ethernet, interface range.
Interface range.
I think 5 and 6, right? Fast Ethernet.
Yes, 5 and 6.
5 and 6.
0/5 and 6. Okay, and this guy will make it okay, no switch port or no switch port. Channel group, channel protocol, PAJP. Okay, channel group. So this guy will take 20. Mode desirable. Okay, channel group has been created now. Correct?
Mhm.
So now let's exit this one. Show Ether channel summary with a question mark. So RNU. So both he has made the Ether channel. One we created 10, another is 20. Still it is down, right? So let's configure for the router now. So let it configure for router. So what we should configure on the router, guys?
We're still configuring the channel as well.
Okay, so let's do that. So go to group and configuration mode, interface range. Okay, gigabytes 0/0/1,
0 to 1.
0 and 1.
1
Okay, so what we should do?
channel group
Channel
20.
protocol. Okay. Okay, with channel group. Okay, so which channel group I think we have created? I think, see, this is
20.
supporting up to 64.
Mm.
Correct. So let's give this 20. And this side, channel group as 20. Channel group 20 does not exist in the configuration. Channel
On the
group,
switch, I think we used 10.
not 20 we have
used
used.
No,
gigabyte.
the one going to the router is 20. The 10 we used for switch to switch.
Yes. So he's asking us to create the new one. So means first thing you should configure with this side. Let's say, let's configure channel group, say example 5 does not exist. Channel group. So group channel number. So let's here 50. So 10
Why
also
don't
is not accepting, 20 also is not accepting. One
No,
also, yeah, 10.
if we get out of the interface,
Mhm.
yes, what are the possible channel or just type channel and then question mark? Let's see.
No, it will not come. When you enter to the interface, then only it will show you. It's showing unrecognized command. We should enter into the interface. No? Interface range gigabyte 0/0/0.
to 1.
These two interface. I want to make these two into bundle, right? So channel group mode, let's say 1. So it's not accepting. Channel group does not exist. We should create channel protocol and enable. So it's not creating. Let's see.
Channel protocol name.
Channel protocol is not working. Channel group, channel protocol is not available. Yeah. Then if we cannot do it, the priority group is there, then it's not possible to do that. Then we can connect other switch, then we can do it. We can connect one more switch how we have connected. Here is created, right? So here it is created. Here we can like show spanning tree. No spanning tree working here. No spanning tree instance are available. I think let me remove this. Why no spanning tree is working here? So span. It's not showing anything, guys. Why? See, but it's showing both are up now. ARM is layer 3.
Yeah.
U means in use, but spanning tree is not working. Why? For that, what we have to do? Show spanning tree. Is it we have to create this one? Trunk link, interface, port channel 10. Okay, switch port, mode, switch port, trunk encapsulation. Switch port, mode, trunk. Okay, command rejected. Interface encapsulation is auto. You cannot be configured as a trunk mode. For the channel group, right? So we are making channel for that group. Show span. That's the reason it's not showing. This thing we can do it, guys. I hope you understood how to make the bundling for layer 3. for layer 3 switches.
Mm-hmm.
You understood, guys?
Yes.
If you have any question, you can ask here. So because just now, if you type show ether channel summary, so we have made it. So these two, we have made it the in use. Is perfect, is working. Yes, I think so. Interface port channel 10, no shutdown. Shutdown and no shutdown. So span. Anyhow, I think you check from this again. It is working now. If you have any question, guys, you can ask me, guys.
One question.
Yeah, Andrew.
In my case, normally when I see that green color, I see that there is that communication, proper communication. In this case, these two switches have got this amber color. I don't know if it means there is all that proper communication, or maybe communication is still underway.
Yes, because it should become the green color, right?
Can we add PCs on each side and test?
Okay, for that, what we have to do? We have to make the trunk link, right?
Mm-hmm.
Okay, I think
Port.
interface channel group. Sorry. Interface port channel 10. Okay, switch port with a question mark is asking switch port mode trunk. So as it is in auto, is showing that one. So switch port trunk encapsulation. So allow VLAN all. So because it is in auto, that reason it's not accepting. We should remove that auto. Okay, that interface port channel 10. Okay, switch port mode trunk. Switch port trunk allow VLAN all. So interface trunk. So still is not accepting the trunk link. Okay, so what we'll do means, so we'll remove the port channel. Okay, no port channel 10. 10 is not there. So ether channel summary. Yeah, it's there now. So no port channel load balancing. How to remove, guys? Okay, so let me. Can you try from your side, guys? You can send me this file. Maybe I think next week. What could be the problem? Shall I take the new one? So let's take two, guys. Same lab, I think they can see. Okay, show VLANs. Okay, show spanning tree. So all are in learning stage, and these guys are root bridge. Fine. So let's start the very simple lab. Again, we'll do ether channeling in layer 3 switches. Okay, what is the first thing we should guess? Okay, interface range fast Ethernet 0/1 to 4, right? Same interface. We say no switch port for this one. So after this, what we should do? What is the next thing we should guess?
The channel protocol.
Yes. Okay. So channel protocol. So which protocol we are using? PHP.
JGP.
Then?
And then channel group.
Okay, channel group 248. So let's say I'll give this time 40.
Mhm.
Okay. So mode, ether mode
Mm.
of the interface. Mode. So mode this I want to use auto or like the PHP. We can use only these two guys. Desirable or auto or
Okay.
passive. So what we can do, so let's use this side as a your auto. Okay. Then what we should do now? No shut command also if you want, we can give no problem. And then show ether channel summary. So it is down now. D stands for down. Okay, it should come U. Okay, the layer 3, it has converted to layer 3, no problem. So the same thing, just do it here. So go to global configuration, interface range, pass Ethernet 0/1 to 4. Same interface, right?
Yeah, no switchboard.
Channel protocol, PHP. Channel group. Okay. How much you have given? 40, right?
Mm.
Mode. So here I will give desirable. Okay. So I say no shut. No need to give this. Show ether channel summary. Okay. So
You
still
did
is
not
it?
do no switchboard.
Yes, very good. Very smart. Okay, interface range pass Ethernet 0/1 to 4. No switch port. Let's
Okay.
see. Do show ether summary. Oh, why is not changing? I think before giving that we should give, right? Okay, so I think we should use this command. Okay, no channel group 40 mode desirable. So no switch port. Oh, it's really getting rejected. Or vice versa. So either port is layer 2 and the port channel is layer 3 or vice versa. I want to make the ether channel. So ether channel. Still it is layer 2.
Mm.
Let's see now. What about this one? Okay, this has become layer 3 and this guy I think is not become 8. Okay, so better to just remove this configuration. We'll do once again.
Yes,
Okay.
that's yeah.
Okay, interface range path Ethernet 0/1 to 4. 0/1 to 4. Okay, so no switch pad. Is not accepting this one.
Let's remove the channel protocol.
Protocol PHP.
Yeah.
Very smart, Clara. You are very intelligent girl in Malawi. Very smart. Okay, so now it has taken, right? No switch port. Now it has taken. So now channel protocol PAGP.
Mhm.
Channel group.
Group 40.
Okay, I think we have given 40.
Mod.
And mode, this side we have given, it should be desirable, right?
Yes.
Yeah. Okay, why is showing this one? Let's say this one also auto.
Rejected.
Just give on. On also is not possible. At least it should take auto. No? So let's see. Show ether channel summary. Still is taking layer 2. But this guy has taken
Yeah.
Hispanity. So Hispanity is also not working. Yes, Clara. So what we should do? Give some idea. Andrew, Sahil, I think only 3 people joined today. I don't know. This is packet tracer, right? Stimulation part. Okay, I don't know how to save this file, guys. No. Let's take the switch. Yes, so let's configure this. Interface range for Ethernet 0/1 and 4, right? Same. Okay. I say no switch port. Channel protocol PAGP. Channel group. So channel group I say 10. Okay. Mode. Okay, so mode. So what I'm going to do, one side I'll do a desirable first,
Yes.
right?
Mm.
And show span tree first. No span tree, show ether channel summary. So now these guys became our layer 3. So let's check with this guy now. So interface range for Fortinet 0/124. No switch port. Channel protocol PAGP. Channel group. So what is the number we have given? 10, right?
10.
Okay, and mode.
Auto.
Mode auto. Yeah. Show ether channel summary. Yeah, so now it is
Yeah.
in use. Perfect. Okay, I think a link must come up now. Show ether channel summary. Okay, got it. Perfect. In use. But Andrew questions is not yet solved because it is become the amber color. spanning tree is not working. For that, we have to make the trunk link, right? Okay, so what is the port channel? Okay, interface, port channel, 10, right?
10.
Okay, then switch port. What we should do? Switch port mode, trunk. It is auto. Switch port, trunk. It is in auto. If you make trunk link, it will come. Show interface trunk. Show ether channel summary. Okay, what about this one? Show ether channel summary. Yeah, so both has became the layer 3, no issues. Both has became the layer 3, no problem. So this is how we can configure, guys. I think you want this file, guys?
Yes, please.
Yeah, so I'll save this one. I think this is our layer 3 lab. I hope you received, right? Files, 2 files I have shared you.
Received.
Okay, so anyhow, guys, I think ether channeling, because some more topics like your PAP, CHAP, like network security. Okay, if you have any batches running, guys, for you only people, because this shows that you people are very much interested, guys. Especially Andrew, Clara, and Sahil Ghani. So I would like to thanks for these 2-3 people are very dedicated in the training. And thanks for sitting in my training, guys. So few topics are missing, guys. So maybe in coming batches, we are going to start the batches on the camera. I'll off my. So in coming session, guys, so we are going to start the new batches. In batches with the topic missing, I'll share you the link. You can join this training, guys. No problem.
All right.
Okay, if you are missing, so because I like the people like who are showing a more interest. So I could notice that you 3 people are very dedicated, guys. So if you could on your camera, guys, let me see you guys, because I have not seen you. You are seeing me every day, every week. Andrew, at least show me your beautiful face, man. Because we are very firm. Oh, Clara. Hi, Clara. This is the first time I'm seeing you, Clara.
First time?
Maybe, I think. But I see your photo in your WhatsApp. That's it. And with your baby. It's nice to see you.
Thank you. Nice to see you every.
Yeah. Then how is going this thing, Andrew?
Yeah, going on well. I've learned
nice,
a
man.
lot, and I think it will help me in my career as I'm You know,
Mm.
with these IT things, I need to learn at least several things so that I cope up with the environment.
No problem, guys. Because I used to train many technology. Okay, so for you, 3 people, I will share you the links. Okay, with the specific
Yeah.
time. Because no, I want the people who are showing interest to learn. They want to develop the career means then only I can show the interest, right?
Mm.
We can see the first day it was I think 17 or 18 people. Then it has become 14, then 12, then 11, then 9, and today 4 people, including me. How was training, Andrew and this one, Clara? How was the training? You want me to improve because maybe I think we Indians speak English sometimes very fast, sometimes slow.
Mm. But it's been a really good training. Maybe sometimes you do go fast, especially when you're using the presentation, but then with the labs, it comes very clear. So it's been a good training.
Mm-hmm.
Mm.
Yeah, in my case, it is been first time to be taught by someone from India. So
Okay.
learning even the accent of the English from India has been a challenge as well, but I had to cope up.
Okay.
Sure.
I think this is the first time because you're learning because is a group which you are there. So he was my students. He came to India for the training for CCNA and CCNP 5 years ago.
Okay.
Mm.
All right.
Yeah. So can we stop the training and we'll see you guys in the future. Definitely. We look forward, guys. So let me know if you have any work, any project in your countries. Definitely we are ready to work with you guys. If you want any support from our side, I'm available anyhow. You got my WhatsApp number, right? Directly you can reach to me.
Yeah.
Fine, guys. Where is Sahil Gani? I want to see Sahil Gani. Are you there? I think he joined. I think I don't know. Sahil Gani, are you there?
All right, but thank you very much for doing this, Mr. Taj.
Thank you, Clara. Thank you, guys. See you. All the best. Take care of yourself.
Thank you.
Thank you, guys.